Welcome. In this pre-recorded class of Jeff Masterclass, I'll be able to show you all what you need to know when working with a dataset in aspects of data science. One thing you should know that the data can be structured or it can be unstructured. And once you have a structured dataset, you need to know how to deal with a structured data. Okay, first, this is a pre-worked solution. I'm just going to explain what you should do or what are the objectives that you could derive from this dataset of the UCE Results analysis by schools. Now, whenever every analysis is being done, you need first to import the popular library. I'll go over this very fast, then slow where I need to slow down. Import the libraries NumPy, which is a numerical Python for handling numerical data. When you hover over it, you would see they contain arrays, mathematical operations, linear algebra, and then the generation. Then you also have what they call matplotlib, which is for plotting, PANDAS, which helps you for data manipulation. Then this control here is just basically you need to control display of seaborns, your graphs, so that the graphs do not become very big, so you can implement this. Now you need to load your data set. You do loading, which you create first a variable for a data frame, which is df dot pandas read underscore, then the data set data set name. Sometimes your engine may refuse, then you need to do an encoder. With that particular encoder, you can use an encoder to use the other standard. Let me see if we can have that part of the encoder also implemented. Sometimes when you're dealing with the encoder and then the engine to Python, so this helps to deal with the encoding bit of it. Okay, now when you look at your data set, you realize that with the unstructured data, the data is not organized, and you must first organize the data. So when you look at this data, the rows are there and every data is under that data. So that is one thing that you can do to deal with the data. Then another thing that I want you to do before you even think about cleaning any data set is to look at the category. What are the categories of this data? Are they to analyze this data, because you need to look at the categories. Are they in terms of numerical? Do they contain numerical values? You see here they contain numerical values and can be divided into discrete data. Okay, if you look at them in this form, if the data are whole, okay, or we can look at them in terms of continuous data, like in terms of numbers, but these are discrete data. Then we also look at the categories, the categorical, is this data containing, can it be measured against each other in terms of maybe like training, whether it contains categorical data that can be measured against each other, like so this data is ordinal. You can look at the grades against against the school. Okay, and this is one of the good thing with ordinal data. So I've given you the best example. They contain a numerical data. They are also ordinal data, because you can measure these grades here against the schools. So that's what ordinal data means. It can be measured against the school. So now let's move to the next bit of it. Understand the data set. This is just what we call data preparation. Look at the shape of the data. How many rows are there? The rows are 17,639, and then the columns are 48. Now you can also check for the information. Okay, check columns. You begin by checking columns. When you look at the columns, you realize some columns contain white spaces. It's better to remove those white spaces in that preparation bit of it. So once you know that they contain white spaces, you can use this code here to strip or remove the white spaces. So this is going to be our columns after removing the white spaces. So this is a pre-work solution, and it's in our pre-recorded class. So I'm not going to write this code because it's going to take a long period of time. So I just decided to have it working, and then we'll be able to move with it. Although there are some other things that I have not yet fixed, but it's worth explaining it to you so that you understand how to deal with this data. Okay, now once you remove the columns, now you have removed all the white spaces. You want to replace white spaces maybe with an underscore. You can use this code here, basically, that helps you remove those white spaces, because sometimes these white spaces can disturb you when you're dealing with the ordinal dataset. You want to measure them against the columns, and then maybe if you have not written, maybe also to help you check if the columns are properly named. So now the first thing that you need to do when you're dealing with your preparation of your data, you need to understand your data. Okay, now the info function here is used to check information of your dataset. Does the dataset contain what they call floating numbers? Now if they contain floating numbers, integer, how are you going to deal with them? So at some point you realize that we have to change from floating numbers to integers, and then we can use the type function to convert the data from float to, so you use the type function to do that. We will see how we will implement that. Then now also you are now dealing with data cleaning. So when you come to data cleaning, there are 4 things that I talked about. You have to look at the empty cells, wrong format, wrong data, and then duplicates. For this particular case, the first can start with the last option of checking for duplicates. You can use the for loop to check. This code helps you. If duplicates are found, it will drop the duplicate, then it shows you duplicates. You print a statement, duplicate found and dropped, or if there are no duplicates, return no duplicates. For this particular data set, we run and check, there are no duplicates. That's why you see here no duplicates found. Then we also check if there are null values, not a number. This none stands for not a number. Okay, now to check if there are null values or non-values, you could definitely run this code, is null or is null any, okay, sum. But I prefer using this code here, which shows you the total of this column. Okay, so if there are null values, you can definitely see this one with 0 means there are no non-values, or there are no empty cells, null values. Then this other one here shows that these are the total of what? The null values that are contained in that particular columns or rows. Okay, basically in these particular columns. Now how do you deal with them in those columns? You check null values in terms of their percentages. Okay, now it shows you the percentage of data which is missing in those columns here. Now this one's where you see the percentages are not there, means there are no data missing. So you can even try to check the missing data, and the graph here shows you if it comes up to here to 1 means there are no data. If it stops somewhere, means some data are what? Are missing. That gives you a picture that you have what? Missing data in some of those columns, which is okay. Then you can now go ahead and check the number of rows and columns which you have done, and this basically shows the number of rows which contain null values in this code here. So you can use this code to compute the number of what? Of columns. So you realize that there are 14,511 rows that contain null values or empty cells or not a number. Now the none. So how do you deal with such data? Once you need to remove rows with school name, as you need to remove rows without school names, because if a row doesn't contain a school name, it's going to be difficult to deal with it. So you definitely have to what? Remove the rows that does not contain the school name, because you cannot add any school name. Then you also need to replace the total candidates with sum of male and female. Now this is where it gets a little bit interesting. When you are analyzing any data at a UNEF level, you need first to look at the total candidates registered in that particular school, and the total candidate can be determined by getting the total male and female. When you add the total of male and female, male candidates and female candidates, you will definitely get total of male candidates and female candidates. You will get the total of what? Of total candidates. And once you have the total candidates, it starts streamlining your data. You may forgive me from this point here. As I tried to run on this other data, it was not able to show it to me. So I'll just continue explaining this from this other part which I tried to redo it and it continued working. So this is the part which I'm trying to explain. So this shows you the total of this particular one. We are checking if the total candidate is not equals to the total of male plus female. Now when you look at this part which it returned, these schools here, I think about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For them, their total candidates of male and female do not match with this column, with this total candidates. When you try to add this plus this, you get 104, not 105. When you also add 16 plus 22, you get 36. No, 38, not 39. When you add 71 plus that, you also, okay, when you add 24 plus 25, you get 49, not 50. So I think they are less. So how do you deal with such situations? You clean the columns in the total candidate that is not equals to, using this formula, 4 rows not equals to this variable, then you definitely, and it will clean. Now when you try to verify, now it shows you 0 rows, 48 columns. Shows that all the total of candidates that now is the same. When you try to add female and female, it gives you to this total. That is how you do the cleaning. Now this was a data set of candidates before to check the data type. That's why I said to check the data type of the candidate, you just use df candidate d types and shows you the total for this column, total candidates. The data which is there is a float. Now you need to convert the data to be an integer for easy manipulation or calculation. So you just convert it using to this as type, which is used for converting, as type method, which is used for to convert as type int, then to convert it to an integer. Now this is the part which gets a little bit interesting when it comes to data cleaning. When you're cleaning your data, it is important not to make an assumptions, but you can use what I explained to you, the correlation. Remember, correlation, the default correlation is the Pearson's rank correlation, which is returned within what, which is the default for Python. But remember, there's also the Spearman's rank correlation, and then the Kendall correlation. Okay. Now correlation basically shows the relationship between the columns. Okay, that is what you can use. Now let's try to look at it in terms of correlation, because this data set which we look at it, they contain results, and those results, it's important first to get the total of candidates, and then you can look at performance of candidates. We're dealing basically with the performances of candidates in different grades, grade 1, 2. So it's better to generate these grades for each percentage, so that is easier. So this is the code that generates that grade. I'm not going to explain all these codes in bits, but because of time, I'll just try to go over it. And then if you want to get the coefficient, I'm going to just show you how to handle this logic, which basically handles what, the logic which I use here for handling what, because to handle the non values or non numbers. So you can also use this logic here, generate grades in terms of percentage, which you can use this, generate the grade. Then you also use this, you get time and try to understand this code. I just want to explain this because it might take a longer period of time, and it's not difficult. I know you try it out. As you're trying it, you will understand this. Then also getting the coefficient, you use this. Now once you get the coefficient, what is important here is that you're looking at the total of candidates, you divide by what, 100, so that you get the coefficient. Now once the coefficient is 0 in that particular grade, so what you could do, whenever you have a coefficient which is 0 in those columns of total candidates, male or female, then once you have that, it is much clearer that you need to know that the data is within all that column. So you could now fill the remaining values with its coefficients of the grade if it is 0. Remember, the grades as 1 to what? 7, because those grades should add up. Okay, so you could use this, and then whenever the percentage grade is also 0, you can also, of the non-grade, you can also replace it with 0. That one is okay. Okay, after getting the coefficient. Then also remember, as part of this, you go in percentage, you go descriptive. Okay, then you can also use, whenever the grade is 0, you try to replace the non-grade with 0, and then yeah, because you have used the what they call the coefficient. Now, using coefficient to calculate, now you can use this code here, which will help you be, it's just a logic that you can write total mail, what you would understand that. But the only difference here is that, remember I talked about the PEP 8 guideline for writing your code using the snake case, but this code is written using the camel case. So you basically be able to forgive me for that, because it was written some time back. Okay, so you can look at this abstraction, get this, and then you get this for missing. You can sum up all these missing candidates, then get the total summation. Now, when you have this code here, I hope this is okay. In case, you can pause the code. This part is long. Maybe I can scroll it for you to see it. It's only just this code here, up to where it stops. So this is where the work really gets in for dealing with null numbers. You need to write that logic. So this is the logic which can handle that. Just in case you're not seeing something that I've not shown you, you can pause the video and then rewrite the code and understand it. Okay. Okay. All right. So now that helps you to remove or deal with what? The null values. Then here, the number of rows with null values after running that algorithm that you have written. It will show you the number of rows with null values before was 14,000, which we looked at it. Now, after running that algorithm for cleaning, then you see the number of rows after running that algorithm is now 0. Now that is okay. Now you can check if there's any null value. Is null, you realize they're all false, or you can use the other total to sum. It will show you that what they are still false. Okay, I can try to show it to you here where I use the logic. This is the logic which I use, and when you try to sum, now you see you can use this code also. Check for null or non values after running that algorithm for cleaning. So realize now there are no what? There are no non values, not a number. Okay, then you can also check for school columns. Okay, school in school. Then remember I talked about using the regex, the regular expression. Remember some schools here are written in short forms, what? So you could try to rename them using this regex formula, this code here. So when you do that, then definitely it should be able to realize some schools contain, like schools like Kamudi, Masaka, they exist twice. So let's just proceed with this well-written code. So when you rerun this particular code here, it will show you when you run this code for wrong format. Remember I explained wrong format is how the school is written. Here there are no box number, there are no, some schools does not contain box number, some schools they are written in acronym which are not okay. So now how do you go about dealing with that? Okay, you can, this is before, you need to write that this code here. Now when you write this code here, this code cleans the column of the school. Remember using the regular expression where there are those gaps which are missing, you can put it so that it organizes for that using the regex, the regular expression which we talked about it. So this is the code that does that. But of course it's not difficult, just need to understand the pattern from the other code. Now this now returns a very clean column for the school names, the three others, how they are written. Okay, then you go straight to check if the schools contain what, if they are repeated. You realize that for districts, basically, you realize districts, some districts are repeated twice, like Kamuli or Masaka. Then you try to clean up, okay, like print sort. First show you all that. Then after cleaning, you use that code to get the sorted column arranged. Then you use this code here basically for cleaning the district. This splits and then this cleans. So now this is going to be schools which are not repeated. Now you filter out year and total candidates. So remember, year and total candidate, those columns are already okay. Okay. Now you just filter out. Now you see how many, the year, the total number of candidates. Year 2021, those are the total number of candidates. Now, getting the total candidates per year, okay, maybe just, but this may not be important. This part of the code may not be important, but if you need it, you can use it just to highlight for you that part where there are years. So here now you see year, this were the total number of candidates, 2012. So this also helps you to understand the pattern of registration, how candidates have been registered. So you realize the year where candidates registered, where many candidates were registered for UCE exam was 2016. But this can also help you to understand not drop rates of students from school, but shows you the pattern in which our candidates are being registered every year. Okay, that would be a very good objective to look at it. Now here, now you have a very clear objective. Look at the registration of candidates per year. Of course, that is also what they look at it when you're analyzing your data. The way UNEP represents their data on New Vision newspaper, when you go to UNEP website, and then you realize that UNEP basically look at, the first important thing is the total candidate registered. So that's the most important thing that UNEP looks at it. When they look at the total number of candidates registered, you can look at them in terms of percentage of candidates registered in which year. Then once you look at the registration, then it's now easier now to look at what? The performance of candidates. Okay? Now when you look at the performance of candidates, first here you just look at the candidates who sat for UCE exam in each year. So when you run that code, you can plot a bar graph or a line graph. You can use a bar graph horizontal, this is horizontal or vertical, to show you just basically, or a line graph to show you what? The performance, how candidates are registered, the total number of candidates who registered in each and every year. So you realize 2016 had the highest number of candidates who registered. And please always make sure that it contains the title, the title bar, the year, and then the y-axis, and then the x-axis label. It is always important to do that. You could also go ahead and show the data labels. Okay, all right. So this is the code that helps you. Make sure you set this to year, enter, align, and then also should be able to put the title, then set x-axis total candidates, then y-axis you could also say here x-axis label total candidate. Okay, so that helps to set what? The x-axis to be what? The total candidates, and then the other one to be the year. Alright, so once that is sorted, you can come up with this graph, and then you can also filter out total division 1, division 2, and division 3. So here you look at basing on the grades, maybe like year grades, then you look at the year and then the total of division 1. In this year, how many division 1 are there? Division 1, division 2, division 3. Okay, so you could also look at the total, basically division 1, division 2. So once you filter it out, it shows you that the total candidate each division per year. Then now you can use this total year grades, total candidate division per year. So how many division 1s were there in the year, that year? This were that, and then highlight and shows you the number, the columns with the highest number of total division 1, division 2 in that order. So you use this code here to do that. Now once you have this, you now have the year. Now you can also plot maybe a graph for year against division to show you, maybe a pie chart, bar graph. Now you can come to 2026 and then maybe look at maybe that's another objective, to look at what performance of candidates based on division. So you can have a bar graph showing UCE candidates in a given year. So now this in 2021, their performance based on that. So you can use a bar graph. So if to see, I'm just going to show you this, the code that does that. Remember, you should always have a title, and then the X parameter name, and then the Y parameter name. So which is the title is going to be there, and the X axis is going to be here. Okay. Then this is going to be what? Supposed to be total. It's here again. It's supposed to be division, which you can implement that. Then also represent the performance of candidate in each year. Okay, I'm explaining this basically for you to get it right. So especially on this data set, so you can represent the number of candidates in each year per division using the it map. So like 20 total division year, and then using it map. So you can have heat map showing candidates in a given year. And you know what this heat map comes from? Correlation. And now it shows you the performance, where you see it's less maybe concentrated, just basically using the other approach of the heat map of correlation, be able to see the correlation of these performances. Okay, so here basically shows the performance of what shows the total candidates in a given year per year. Then you can also go and look and represent this in terms of what? Total candidates per year and with the grades. So total candidates and the total grades. So general performance of the candidates, maybe for 2016. And then you can also go ahead and show maybe the performances of the candidate in the year 2016 per school, then the total of candidates, and then the total division. You can also show that. This is the code that can do that for you to get the candidate who registered with the worst performance in UCE. Okay, maybe failure rate and then the passing rate. You can look at it in terms of the different grades. Then you can filter out schools or districts by counting out schools. Okay, so how many schools are there in each and every district? So you can use this code here. It will show you Wakiso there are 352 schools, Mukono 126 schools. You can count that using this code here. Okay, frequency, then you get the total number of what? Schools, using the index for what? For schools. Then it will just district and district, then it will get use district to get schools. So it shows the number of schools. That is the only school with only district with only one school. Then plotting top 20 districts with many schools. Could top maybe like head, you just pick head 20. Just this head method only just pick only the first 20. So the first 20 district with many schools. So you realize Wakiso, the data is you can plot using line graph or bar graph. So this is the data visualization bit of it. Now you look at data visualization. So you here see the districts are here. Now this is what, because it's picking only one column. Now basically it will be able to show on what? The district. So this is a district with the many number of schools which are having many O-level schools, which is also good so that you know how to print the material. So remember, I talked about this data science analysis helps you in three things: better decision, predictive analysis, pattern discoveries. So here basically we are looking at what? Pattern discoveries. Then you can also see better decisions. Now we look here at also determining the general performance per district in a year 2016 by filtering out total candidates by division 1. So 2016, let's look at the performance in terms of division 1, division 2, division 3, division 4. Okay, then the total division 9. Now this is basically looking at only you filtering out to determine performance per district by basing on division 1, division 2, division 3. Okay, that's why you write this code, the as type integer, then you get this. You see a beam total candidates, division 1 there were 9. Germany they had only 15. So this is exactly how they represent this in what? In they analyze this data that you see on newspaper and what. Remember, this is the only way they can analyze. The schools are very many, but now when you understand this, you can be very good at analyzing data. Then also to use this to calculate overall district, maybe like look at performances of number of schools. Okay, now in these schools, number of schools are this, total candidates are this, how many divisions are within Wakiso. So here you can look at maybe the total performance of division per district. Okay, yeah, so you can also look at that. Then you can also calculate maybe the total candidates per district. I don't know whether I've shown all this code. Okay, this is the one where you maybe I scroll for you to see overall district performance. Now, which district performed very well? You can use this code. You have seen this in the newspaper, New Vision, Daily Monitor. So they use data analysis for this. Basically, that's where now data scientist comes. So here you'll be able to see district. You have how many candidates. So you have about but of course, if they have an AI system, definitely the AI system will do this. But in an event, you know, most systems are static, they're not dynamic, so you have to extract the database and then analyze this data just like this. So you can see district like Wakiso, they had the total were here, overall district candidates per school, this were per school, they had this total number. Then you can also look at the candidates, filtering candidates columns 2016. So you can see the total candidates per district. You can see them, they're there. The school with few candidates were Amudat. You can see that means people are not studying in that school, Amudat. Then you plotting maybe top 20 district with many UCE candidates, the schools which contain many UCE candidates. So you can have district, maybe just use column head 20 just to show you only the first 20, top 20. Put top 20 or 10, shows you candidates with that. Then you also go filter out total division 4, 5. Basically now this shows failure, the failure rate, district that fails, because division 4 to 9, definitely that's failure. So division 4, how many are there? That's the number. So schools that had the highest number of failure, of course this is just based on total division. You see Wakiso comes first because there are many schools in Bale in that order model, so you can see. Then plotting failure rate, so you can see of maybe like top 20, so you can see here. Okay, division 4 and division 9, so you can see this is district. Then you can also go ahead and look at identify top 20 schools that contribute to the highest failure rate. Which are those schools? Queen, Bushia. So you can use this code here to get schools which what fail. Now this all helps in better decisions, and this is objectives. Look at schools that fail students. If that, you can derive very many objectives from there. Then identify top 20 best performing schools for over considering year 2021 where we observed the best performance. So you can also look at it in this. So so here identifying best performing schools, looking at 2021. So you realize Gayaza is the school that has been performing well, followed by this is what you see, performance of schools based on this. So you can use this. Then identify the top 20 best performing schools in 2026. Remember, we look at 2021 now, 2026. Still St. Academy, Lawrence, Budo, St. Mary's, Chitende, Uganda Matters, Gayaza High School, Torre Dema Academy. So all this you can look at it, top 20. Then you can also sort them to arrange them alphabetically. Then you see Gayaza, okay, these top performing schools, to arrange them in ascending order. So you realize Gayaza High School camps, Namliango, St. Mary's, Namagunga, Uganda Matters. Okay, then you also use this other part also to show maybe in terms of performances of schools that has maintained their performance in both the years from 2021 up to 2023. So you can see schools that have been maintaining their performance using the graph, schools and the graphs. Okay, then calculate the percentage of division 1 attained by each schools to determine the best performing schools. So you can use this to get the best performing schools, so you can use that. Then to filter out division 1 per district, if you want to know how many division 1s were there per district, Mukono had about that's the total of division 1 in terms of percentage per district. Then you can also plot a bar graph to show the performance of those schools per district. If this code is long, probably I can scroll it for you. And that's how you can implement this. Okay, then you can also determine the correlation between the school. Remember, it's also used to look at the correlation. Now correlation basically helps you to understand the relationship in those schools. So now if it is performing well, one positive correlation, good, so you can use that. So with this you can use regression. Remember, I've mentioned one thing, that data science covers three parts. We have what you call the data science statistic, which deals with percentile, standard deviation, variance, correlation matrix. So all these correlation things comes into terms of what? It comes into the advanced bit of data science deals with linear regression, regression table, regression info, regression coefficient, regression p-values, regression R-squared. So all this you could try to learn them on your own, okay? But this is what you could use and helps you group probably to earn more points when you do your work like this. Okay, then explaining results merge in 2026, so you can use the describe, so that you can gives you the descriptive statistics. Okay, now here when it comes to descriptive statistics, you look at the mean, standard deviation, the minimum value, maximum value, counts also the value. So you can use this just to get you the data of 2026. Then you can count the rows. Of course, you can go ahead and do that. I know it will take a lot of time, but let me just explain this faster. Then cumulative analysis made by the general performance of male and female. So when you want to see the performance of male and female, so in which year that. Now plot maybe a bar graph showing females and male candidate per year. So you realize that the black one are when you look at this visualization, you realize that in all the years the male have been registering more male sat for UCE exams compared to female. Then identifying the year where candidate had maximum numbers of each division for each male. So the years with maximum numbers. So this could be the code. You could try to check it if that's not shown. Stop it and check. So it could show this, can highlight for you the years with what maximum numbers of each division. Then also you can plot it. Now once you plot it, it's going to be easier to look at division 1, which is the blue one. Okay, division 1, division up to 2026. So division 1 are normally few, and when you look at division 9, that means majority of the students throughout those from 2021 to 2023, majority of students are in division 4. That means there's higher rate of failing than what passing. That means the green one, from green, yellow, orange, and blue, those are the ones which have passed. So there's high rate of failing in those years. So plot showing total number of males. So you could also show the total number of what male in terms of their division. So you realize also the blue one up to that division. Then comparing females and men in terms of division 1. So you can also have this total of male in division 1, total of female in division 1, division 1 and 2. Okay, You can compare that. Then you can plot a graph to show performance of male. So you realize here the female is the red one, the blue one is the male. So you realize that male perform better than female in both division 1 and division 2 based on the graph. But there's only in this year where 2011 female perform better than male in division 2. So you can analyze that data using that descriptive statistic. Okay, so you can go about that, and then you also look at cumulative males that lead in that division. You can have a bar graph. Then you can also go ahead and look at top 10 districts where females fail mostly, districts where females fail mostly. So you can look at it here. So with division 9 and division X division, so it shows you Wakiso, Mbale, Kampala, Iganga, Jinja, Kamuli, Mukono. They had them where female fail. So you can use this code to do for you this. But definitely when you have the logic, you can figure it out. Okay, then top 10 district where males fail mostly. Shows you district where males fail mostly. Kampala, there's Arua where males fail mostly. And now this gives you a picture. Then this district with the number of female and males cumulative. So you can also look at that in terms of this. Could look at 10 of them, so you can see bar graph showing district that educated the highest number of female since 2021. So you realize Wakiso, Kampala, Mukono, these are where they had the highest number of what? Female candidates. Okay, the UCE accumulated females since 2021 to 2016. So you can use this code. In terms of percentage, shows you that male candidates are more than female candidates. You can use the pie chart. Now, there's one thing that I want to talk about is that whenever you're dealing with data science, you could also go ahead and look at the advanced data science, which deals with what? Predictions. Remember, I talked about 3 things. Data science helps you for better decisions, predictive analysis. Now, this is where you can predict maybe enrollment, what. You can use this also. If you have this in your final project, you get more marks. Predictive training of the data. And then pattern discovery, discovering the patterns of division 1 and 2. So there are 3. 1, why you do this data analysis for better decisions. You decide help for decision making, data driven decision making. Then 2, predictive analysis. Now this is where we enter in the predictive analysis. So the predictive analysis now here, we can basically look at, we can even know that maybe these are the schools that the data set proposed that now these schools are likely to perform very well based on the data. So we can use that, and then we do the encoding strings, and then, which I know we've not covered it, but you can try them on your own or in your group. Then you check out for the futures, and then you try to y for train, and then x for train. Then you do some future selections, the rates. Then all this I told you, I'll just be able to show you this. Then you can try them on your own. Then do this x drop. Then you now do using the circuit learn. Now this is where the ML comes in, the machine learning comes in. The circuit learn to learn the patterns into your data. You split some x for training. Maybe here we are using 10% for testing, and then the testing is small, should have actually been 20, but also based on the data. Then the other one for testing. So you look at the training score when you run this code here, basically for training. Then you get this. I haven't installed some modules here, that's why you see there's some errors here, problems here. But all this, you just use pip install them. Then you can also do the predictive modules, whether female will perform better than males in terms of, so it be able to show it to you. Then you can also look at the relationship between the predicted and the actual. So you can basically show this code. Now when you try to draw your scatter plotter, which it's also good for looking at predictive analysis. Predicted male is that, predicted female. Now this helps you to get to know maybe you predict that, okay, maybe we are going to have 60 male in division 1 and female we are going to have maybe 80 basing. So this predictive analysis can help you understand. You can predict female also against male. Now this type of correlation where it is not properly distributed, this scatter plotter which is not properly distributed, definitely shows you that what it's going to be a bad a bad correlation. So that is it. You can now look at one last bit of it, which I'm just going to show it to you. Now, basing on this training, you can try to do that training predictive analysis, which is a good thing for your group. I'll also try to make sure I explain to you, but because basing on the way we have seen it here, this data set is not performing very well because of the limited data which is there. But otherwise, this is how you go ahead and do your analysis. Okay, so just to summarize it here, you need to understand that whenever you're doing your analysis, it is always important. It is always important to look at 3 aspects when you're doing data science work. You need to look at better decisions, you look at predictive analysis, and then you look at pattern discovery. Discover the pattern of registration, how candidates have been registering. So to summarize this, the other core aspects of data science in math, which deals with linear function plotting and then slopes and intercepts. Then there are also other data science which are for statistics, like percentile, standard deviation, variance, correlations, correlation matrix, and correlations versus causality. Then we also have the advanced bit of the data science, which deals with regression, the regex, linear regression, regression tables, regression info, regression coefficients, regression p-values, regression R squared, and then linear regression cases. So all these are concepts that whenever you're doing any data science project, this is how I expect you to present your work. Thank you for watching the video. Thank you for following. Now you have all the objectives for analyzing your data. I wish you good luck. Try it. If you have a problem maybe writing this code, these codes are not difficult. You have now known how it can be implemented. You can try them. I'll always try to get time, create content, share it onto this Jeff's Job Masterclass. Throughout your learning, you can come back, keep checking on concepts that you feel you have not understood on this website. But please subscribe, click on the notification, and then like the video so that but the most important thing, subscribe, turn on the notification so that every time I have looked at a problem and I'll figure out a solution, I can do it, upload it online. This video was going to be very long if I was to write all this code, so I decided just to explain the code. I'm not going to share the code with you, but because part of the code might not be working, so I need first to figure it out all and solve it all for you, but it should be able to run normally on your computer. Okay, thank you. Catch you on the next class for machine learning. Okay, the machine learning basics. That's where I will be handling most of the things there. See you. If you have anything that you feel is not working, please leave a comment. I'll try to look through it, and I'll just under that part try to do it practically, and then you'll be able to have that sorted. Bye bye.